Hello, I'm Michael McCabe, Product Manager for RFID at Pepperl+Fuchs. If you are already comfortable with IOLink and you just want a refresher on how to read and write to a tag, skip ahead to video 6. But if you are not 100% sure on how to get to that point, don't worry, I've got you covered. In these first 5 videos, I'll discuss every detail so that you can hook up an RFID and IOLink system. I'll make sure to give extra tips and backstories for further explanation. In general, this entire video series will show you how to hook up a sensor, in this case an RFID head, to an IOLink master, and then use that awesome web interface right on our laptops to start exploring IOLink settings, capabilities, and more. I want to help you lay a really good foundation. So check out that information section on this page to see outlines for each video in this series. So first up, in this video, I'm going to show you how to select an IOLink master, hook it up to the laptop, provide power to the IOLink master, discuss the IOLink master's IP address and find it in PortVision, make sure the laptop and IOLink master are on the same network, and open up the web interface in a browser. Let's get started. First, the web interface works great for demoing. It won't show you how quickly we can read and write to a tag. We have other ways of showing this, but it does a great job presenting which parameters may be changed and the amazing amount of data that IOLink provides. Alright, so for our IOLink master, I'm going to be using the ICE2 block because in this scenario, I'm imagining that the application uses Ethernet IP, very popular in the US. If you need something like Profinet, try the ICE3 block. I'm going to hook up the ICE2 block to the laptop's Ethernet port using a decoded connection cable. Shown on the screen is the cable that I'm using. Depending on what you're doing, instead of a laptop, maybe you connect this cord to an Ethernet switch or a PLC. I'm going to connect to Ethernet port 1 at the bottom of the ICE2 block. You can see that there are 2 Ethernet ports, which allow for daisy chaining if the application calls for it. A connector cap should be added to the unused Ethernet port to keep out fluid and dust. Decoding is shown here in the middle. Notice it's used for Ethernet. Next, I'll hook up some power using an L-coded cable, also shown here. Here is a closer look at L-coding. I'll plug it into the power in port at the top. Then, I'll simply connect the brown and blue leads to a 24-volt power source. Again, shown on the screen is the cable that I'm using. Alright, so now let's make sure that we're working on the same network. By default, and this is shown on the back of the ICE block, the IP address is set to 192.168.1.250. You can use PortVision or the web interface to verify and change the IP address, so let's open up PortVision DX to verify. Download this software for free by going to Pepperl+Fuchs website and typing PortVision into the search field. So go ahead and click Scan, and make sure to select IOLink Master, then click Scan again, and we wait. Click on your device, and then over here to the left, you can see the IP address and also the MAC address listed. If I click on my device at the top, I could update the IP address if I wanted to. Also, there are multiple ways to open up the web interface, one simply being the web page button at the top. But before I open the web interface, I'm going to make sure that my computer is on the same network so that it can talk with the ICE2 block. Alright, so first we're going to right-click on our internet connection and click on Open Network and Settings. Then click Change Adapter Options. I'm going to find my unidentified network and right-click. Click on Properties. And I'm going to update the properties of IPv4, or Internet Protocol version 4. Now, if you ever scroll down just a little bit, you'll see that there's actually an Internet Protocol version 6. So you may wonder, why are we changing the properties of Internet Protocol version 4 when there's a newer version available? Well, Internet protocol is just an addressing system used to identify devices on a network. Mostly, we see customers using Internet Protocol version 4 because it's 12 digits, which are actually just 4 bytes, and don't worry about remembering that now. Those 12 digits provide enough addresses to handle all the devices on their network. Internet Protocol version 6 is also an addressing system that provides many more numbers to identify devices. All of them in the whole world probably. I don't remember specifically, but it's more than companies usually need. It ends up being not as easy or widely adopted, and again, in our case, it's just not needed. So again, let's highlight Internet Protocol version 4 and click on Properties. Next, I'm going to fill in the first 3 numbers of my IOLink master's IP address, and then pick a random number between 1 and 255. The only limitation is it can't be the same as the IOLink master, which by default is 250. So in this case, I'll pick 217, again, just by random. Now, let's take a moment to look at this further. Take notice of the IP address. All the portions where the subnet mask below is 255 make up our network. So in this case, the network is 192.168.1. These are the upper 3 bytes of the IP address. The lower byte, or lower 3 digits, identifies different devices on our network. Again, you'll remember that the ICE2 block is 250. So I randomly chose another number, in this case, 217. This is really like saying that the ICE2 block's name is Alfred, and my laptop's name is Larry. Now, Alfred and Larry can talk because they are in the same network of friends. You just can't have 2 people or devices with the same names. That's all. Now, if you look at the ICE2 block, you're going to notice that there's 3 rotary switches on the front. These can also be used to set the lower 3 digits of the static IP address, which again by default is 250. But this method is usually only used in special circumstances. So, if you've ever had trouble connecting, remember that if the rotary switches are set to a non-default position, the rotary switches override the lower 3 digits or 8 bits of the static IP address which we just configured. By the way, what does static IP address mean? Well, it just means that it doesn't change. It's static. Most of the time, when we're connecting to the internet, for example, our computers are assigned dynamic IP addresses, which means that they change. This is not currently what we need. Alright, so our devices are now on the same network. So let's open up the Firefox browser, which is just another way to get to the web interface. Firefox is nice because it should let you stay connected to your current internet connection, while some other browsers may have issues doing this. Go ahead and type in the IP address into the search bar and hit enter. So now, if you're hooking up a new device, you should not be prompted for a password just yet. I've already set up a password, so I'm going to go ahead and type that in now. Alright, let's check out our IOLink master. If the mod LED is solid green, the IOLink master is ready for operation. And if we want to further prove that we're communicating with our IOLink master, let's go ahead over to the configuration tab, click on miscellaneous, and then turn LED flash to on. If we did everything right, our ICE2 block will light up nicely. Alright, so in the next video, I'm going to hook up the RFID head and discuss what cable is used. And I'll talk about some of the pins of that cable. Again, my name is Michael McCabe, Product Manager for RFID at Pepperl+Fuchs. And as always, remember that Pepperl+Fuchs is a leader in industrial automation. So click the subscribe button below to see the new industry-leading products that we come out with. And if I did a good job on this video, please click that thumbs up button so others can find it more easily. Remember, if we don't tell YouTube what's important by giving it a thumbs up, we're going to keep seeing only those shocking and crazy videos which can be fun, but they're not helping us to become the intelligent professionals that we aspire to be. Thanks, and I'll see you next time.